lecture, we were talking about loops in Java and arrays, of course. So remember that Java has two kinds of for loops. It has the type of loop that we were looking at the end of the last class is a counting style loop, right? So you declare a loop variable I in this case, right? You specify a condition when the loop runs, right? And then you specify an update statement, which occurs at the end of every loop iteration. Right? So just to quickly remind you, we're going to declare a variable I, set its value to 0. Right? Before the loop runs, we're going to check this condition. Every time every time we try to run the loop, we're going to check this condition. If the condition is true, the loop will run. Right? So as long, and I in this case is an index, so the loop should run as long as I is less than the length of the array. Right? And then at the end of every loop iteration, we update the loop variable I. So remember, Java has a second kind of for loop, right? It has for each loop. So the for each loop is useful if you want to iterate over the elements of an array, and you only need to look at that element at each iteration. So it's possible to rewrite that max index method using a for each loop. Right? And so for each element in the array, right, we're going to do the same thing. The only difference here is that because I want an index, I need to remember, I need to create a variable to hold the value of the index. Right? And so in this style of loop, there is no explicit index. You just get the element from the array. And so if you want the index, you need to keep track of it yourself, which is fine. Okay, so for each loops are useful if you're going to, if you only need to look at the one element of the array at a time, and it's the element that the loop is visiting in that iteration. If you need to look at more than one element of the array, then it's often easier to use a counting style loop. So here's the isSorted method that checks if an array is sorted. Right? And so remember how this works. It just looks at one element of the array, and it looks at the element in front of it. Right? So we're going to start at index 1, so the second element of the array. Right? And each time through the loop, we're going to compare the previous element, so that's the element at index I minus 1, right, to the current element, which is the element at index I. Right? And that's why this loop starts at 1 instead of starting at 0. Right? Now, you can easily rewrite this method so that it compares the first element and the second element, right, using where I is an index, is the index of this smaller, sorry, I is the smaller index. Right? And this is one of the problems with writing loops in any programming language. There's often more than one way to write the same loop. Right? So this is sorted 2, right? Instead of starting at 1, so instead of looking at the second element, I can start by looking at the first element. Right? And now the loop condition changes. Right? Sorry, the condition inside the loop changes. Right? I want to compare the current element to the next element. Right? So remember, I is the index of the current element. Right? So I would now want to compare it to its next element, so I want to compare it to the element at index I plus 1. The other problem when you're indexing into any kind of index-based container is you always have to make sure that the index is valid. Right? So whenever you see I plus 1 or I minus 1, you always have to look at the value of I and ask, can the value of I ever be such that the computed index is not valid? Right? And so here, the I plus 1 is a problem because this loop runs as long as the value of I is less than the length of the array. Right? In other words, the last time this loop runs is when I is equal to the array length minus 1. Right? If you plug in I here for the last time the loop runs, right, it's the length of the array minus 1 plus 1, which is the length of the array, which is an invalid index. So if you write the loop this way, you have to stop the loop when I is less than the length of the array minus 1. Right? So these are all off. This is an example of an off by 1 error. In this case, it's an error that will cause your loop to crash. So if I put it in like this, right, and I call isSorted 2 down here in the main method, right? When I run the code, you end up with an array index out of bounds exception. right? If you read the error, it says index 5 is out of bounds for length 5, right? You can click on anything that's blue down here. So it says that the error occurred on line 48. So if I click on that, it takes you to the line where the exception was thrown. Right? And so if you look at this for a second, you stare at it for a minute, you realize that you're adding 1 to an index and using it as an index. Right? Eventually you'll figure out that this value is too large, right? Or the loop runs 1 too many times, so -1, right? And now it runs successfully, right? And says false, A is not sorted, right? And indeed A is not sorted. Okay, so that's a second way to write that method. There's a third way to write this method. You can still write this using a for each loop if you like. So public static Boolean. It's going to look similar to this, so I'm just going to copy this here. All right, but instead of using a counting style loop, I would like to use a for each loop. So how would we do this with a for each loop? Okay, so remember what a for each loop looks like? You're going to write something like for each element, so for each element elem in the array ARR. Right? Okay, so the problem here is I need to compare elem to either the next element in the array or the previous element in the array. So in this case, it turns out you can rewrite this if you use the previous element in the array. Right? And so the way you do that is before the loop, you compute the previous element. Right? So the previous element, I'm just going to say is ARR0. Right? So the first element in the array. Now with the for each loop, you have to look at every element in the array. There's no choice. So this will compare the first element to itself once, which is fine. Right? And then after that, we're going to compare the second element to the first, and then the third element to the second, and so on and so on and so forth. Right? At least I hope that's what it's going to do. Is that true? Hang on just a second here where I decide if this is true. So next element, so I want that to be equal to, see, I did all of this in my head before the lecture, and now I'm trying to decide if this is in fact correct. Let's take a look. So we might have to make some changes here. Okay, so if the element is smaller than the previous element, there's a problem, right? So if the current element is less than the previous element, it has to be false, right? Okay, now the trick here is that you now have to update the previous element, right? So previous is now equal to the current element, right? So that the next time through the loop, right, elem becomes equal to the next element, right? I've remembered what the previous element is here at the end of the loop, right? And so this will compare the current element to the previous element for all elements in the array. Well, let's see if this works. And it returns true. It returns the correct answer for at least one example, right? Obviously, if you're testing this, you should try it on more examples, but that seems to work. Right. So it is possible to rewrite this loop as well using a for each loop instead of a counting style loop. Right. Now the trick is that you should always pick the loop that is easiest to write. You won't be able to do this until you have more experience writing loops. Right. I would argue that it's easier to write a counting style loop here rather than using a for each loop here. All right. So if you really like Java's for each loops, you might try to write every for loop with a for each loop, but eventually you'll run into a situation where you cannot. So where you use a for each loop is when you are trying to access elements from more than one array at the same time, using the loop as to access the element. Right? The for each loop lets you iterate over one array. Right? If you need to iterate over multiple arrays, you're stuck, right? You have to use the counting style loop. So if I want to sum the elements of two arrays, right? So I have an array A, say it has 5 ints in it. I have an array B, it has 5 ints in it. I want to sum element by element, right? So A plus B0 A B1 and so on and so on and so on, right? And I would like to return the result as a new array. Oops, sorry. Right, so notice here our return type is an array of int, right? It's equal to the sum of the values of A and B, right? So step one, make an array that we can return, or make an array that we can use to hold the sums, right? Now write your counting style loop, right? Summing elements AI and BI and storing it in CI, right? So CI is just equal to AI plus BI, and away you go. Right, so here we're accessing 3 different arrays with the same loop variable, right? There's no way to do this for each loop. Right, in Python, you would also have to use a for each loop with a range to do this, right? There's no way that you can write a range-based for each loop in Python and compute this sum. Okay, so Python, with Python lists, you have a way to select a list. You can get a sublist from an existing list, which is really handy in many cases. So the slice in Python uses the colon operator. And in Java is used in the for each loop of the array of the list T, starting at the 3rd element, going up to but not including the 6th element. Right? Element at index 2 up to and including not the 5. Right? So 2, 3 elements at indexes 2, 3, and 4. Right? So 0, 1, so 2, 3, and 4. So that should give me the sublist 12, 13, 14, right? Which it does. Right? Slash T colon gives you back a copy of the entire list. So that's the Python way to copy existing list. Right? Java has no slice operator for the arrays, and it has for proper Java lists there is a method that corresponds to a slice, right? But there's no slice array. So you have to write your own method if you want to slice an array. So I want to slice an array of int using a starting index and a stopping index. The slice does not include the element at the stopping index, right? So I want it to work the same way as a Python slice. Now, the slice in Python is a list, so a slice of an array in Java ought to return an array that has the same type as the input array. Right? Now for the slice, the start value should be less than the stopping value, right? Less than or equal to the stopping value. If it's not, there's probably, you either have to guess at what the slice is, you have to guess at what the programmer actually wants the slice to be, right? So here we're going to enforce the constraint that the starting index must be less than or equal to the stopping index, right? So we check, is the starting index greater than the stopping index? And if it is, we say that I can't slice that list, or that array, sorry. So we throw an exception here. Right? There are other things you need to check for as well, but we'll come back to that in a second. Okay, so to compute the slice, you need somewhere to store the slice, right? Because I need to store the array containing the slice, right? How long is the sliced array? Well, it turns out if you take stop minus start, you get the length of the returned array, right? So here, it's 5 and 2, so that's 3, right? And there are, in fact, 3 elements in the returned slice. If stop and start are equal to one another, you get 0 here, right? And so this is legal in Java. You can make an array that has 0 length, right? In other words, it's the array that holds no value. Right? So that's legal in Java. You can, just like you can have 0 length in Python. Right? So we compute the array to store the slice, and now you compute the slice. Right? So I want the elements from ARR starting at that index. Right? So my I in this case is going to be the index that I'm using to access the array ARR. Right? So I is going to start at start. Right? It's going to go up to, but not including stop. Okay. So I is going to be less than stop. Each time through the loop, I'm going to add 1 to I. Right? Okay, so I can get the element out of ARR pretty easily. RRI. The only trick, or the only thing you have to be watch out for here, is when where do you store the element of ARR in slice. Right? So remember, slice starts counting element in slice starts counting at 0. So the index here that I need, right, I have to subtract start from the value I to compute the correct index for the slice. Right? I minus start is 0, first time through the loop. Second time through the loop, right? This will be start plus 1, so that's second time through the loop. This will be third time through the loop. This will be start plus 2, so that'll be 2, and so on and so on and so forth. Right? So sometimes you have to compute an index. Right? Whenever you compute the index, make sure that the computed index is a valid index. All right, what other things do I have to check for up here if I'm using start and stop as an index? Right? So I really should check to make sure start and stop are 0 or greater. Right? Because in Java, you can only have indexes are always non-negative. Right? You should also check to make sure that start and stop are both less than the length of the array. Right? Make sure that they are, in fact, valid indexes. All right, so there is your method to slice an array if you want it. Right. If you want to use that method, you can just call it, again, by the class that it's defined in, so lecture4.slice. Right? Pass in the array, and then the start and stop indexes. Right? Notice the syntax here, compared to Python, is not as nice. Right? You have to actually call a method here. Whereas in Python, you can just use the square brackets and a colon. All right, so there's your slice method, and that's an example of returning an array, throwing an exception, using and computing indexes for an array. Any questions on how to slice an array? Okay, so that finishes up the loops. Of course, like in Python, you can have nested loops, so a loop within inside of a loop, right? It works, the syntax is different, but it works the exact same way. So we're now into the next set of lecture slides. So this is lecture deck 5. After this set of lectures, the material here is the material will change to being not from Python to Java, right? So you'll be starting to talk about Java-specific stuff after this point. All right, so another big difference between Python and Java is the way that its strings work. Right? So Java strings, in Java, strings are of a sequence, a primitive type called char. In Python, a string is made up of strings. So every individual character in Python is just another. So that's not true in Java. So in Java, you write string literals as a sequence of characters between double quotes. Right? So double quote, 0 or more characters here, ending double quote, declares a Java string literal, right? A string that you can write down. The empty string exists, so you can write double quote, and that's the string of length 0. Each one of these individual characters in the string is a primitive value of type char. You can ask for an individual character of the string by asking the string s, right? So remember, s is my variable that stores a reference to a string, right? So using the variable s and the dot operator, you can ask for the character index 0 in the string s, right? So again, this is an index. So strings are an indexed sequence of characters, right? So you can use the indexes 0 up to the length of the string minus 1, just like arrays. Right? So s.char at 0, in this case, returns the r in that string. Right? And so the value of c will just be single quotes r. So char literals are delimited by single quotes in Java. Another difference compared to Python, right? Python strings are single quoted, double quoted, triple quoted. Right? In Java, characters are single quoted. Right? So single quote, one character here, is a char literal in Java. Right? There must be exactly one character inside the quotes. There is no such thing as the empty char. Right? There is a space, so this is fine. The second line is fine. Right? The third line is not. right? You can't write single quote, that the compiler will refuse to process your program. So in Java, the char type is actually an integer type. So all of the characters that you can type in, and even the ones that you can't type in, they all map to an integer of some kind. Right? Value, an integer value that's simply mapped to a character of some kind. Right? Now, exactly how this mapping works is not important in this course, right? But it uses something called the Unicode standard. So Unicode is a standard that's used. The original intent was in order to be able to define a mapping from an integer to every possible symbol used in all languages in the world, right? And it also includes other stuff as well, right? So emojis and other symbols that aren't necessarily alphabetic. But using Unicode, you can write stuff in like Chinese or Japanese or any other language, right? So it is possible, in fact, to write a program using a different character set. Okay, so if you want to know what character values what the range of character values that you can actually use, or what numeric values they correspond to, value of the smallest character, right? Just like you can get the smallest integer, right? So remember, to get the value of the smallest integer, it's big I integer.min value. There's also a big C character.min value and a big C character.max value. What you have to watch out here for is that when you ask Java to print a character, right, it actually prints the printable character and not the numeric value. Right? I just told you char is actually a numeric value, so if you want to print the numeric value, to convert the printable value to an int, right, or some other integer value. So that round bracket int takes whatever value is over here, right, and asks Java to interpret that value as though it were an int. Right? When Java prints out an int, you get the numeric value. So it turns out these values are 0 and 65,535. Right? So what happens if you store the value 65 in a char? Right? Well, that falls between 0 and 65,000, so that's legal. Right? This is a bit funny here if you've been paying very close attention to the previous lectures. The 65 is actually an int. Right? When you write down the number 65, Java says that's an int literal. Right? Normally, you can't store an int value in a char, but Java lets this happen, so this is in fact legal. Right? The range of int is much bigger than the range of char. Normally, you cannot store a wider value, a narrower value. Right? Int is wider than char, right? Holds a wider range. Normally, this isn't allowed. The language makes an exception in this case. Right? So C is the value 65. If you actually print C, you don't get 65, you get the character A. Right? What is the type of C? Well, it's a char. Right? There's a version of print line that takes in a char and prints the character value. Right? Not its value, but its actual character value. So here you get the uppercase A. Plus equals in Java means take the variable C, add that value to C. Right? So C plus equals 25 means assign the value C plus 25 to C. Right? So this is also legal, which again is also a bit funny. That's an int. You're adding an int to a char. Ordinarily, Java won't allow that. The language is rigged so that this is fine, right, or acceptable. Okay, so if you add 25 to C, so that's like moving the letter A 25 positions to the right, I guess, or 25 positions down the alphabet. So not surprisingly, that gives you the Z. Right? Okay, so you can do arithmetic with char. I just did it. I added 25 to the value C. So the language does let you do arithmetic with char, but the results are very unintuitive, especially when you use int values in combination with char. Right? What you expect will happen doesn't always happen or is not allowed to happen. It's very strange. Right? Okay, so I'm going to start with the letter A. Right? Can I write C++ or ++C? The answer is yes, you can. Right? What does it do? It adds 1 to C. So it adds 1 to A and it gives you the B. Right? So if you were to print out C here, you would get the letter B. Right? Can I write C plus equals 1. Remember, 1's a char, is an int, right? So I'm adding an int to a char. So does this work? It turns out the language lets this happen, right? So A, now B, so C is now equal to the capital C, so that's fine. Minus equals means subtract 1 from C and store the value back in C. This also works. So A, then B, then capital C, now capital C, right? And so if you look at those first few examples, you say, well, I can add 1 to C to work. If you actually try to add 1 to C using the plus operator, suddenly the language complains, right? It says, hey, right? What happens here? So in Java, plus 1, right? The way Java determines what kind of arithmetic to perform is it looks at the type of the two arguments, right? C is a char, 1 is an int, right? So remember, if you ever do arithmetic with 2, you always get back an int. What I didn't tell you is what happens when you do arithmetic with 2 different types. So here's char. The rule in Java is Java converts the smaller type or the narrower type to the wider type. So it sees char plus int, so it converts the C to an int, and it performs int arithmetic, right? So that becomes the int equal to A, which is 65. Adds 1 to it, and you get the int 66, right? And now when you try to assign that back to C, now the language complains. It says, hey, you're trying to store an int in a char, you can't do that, right? And so you'll get an error that says something like cannot convert from int to char, right? Notice arithmetic is unintuitive when using chars, right? Be very careful when you do it. It gets weirder. Hang on. It gets even stranger, right? So here I have the char D, right? And its value is B. Can I add A and B together? It turns out you can add them together, right? But if you try B, the language barfs. Right? It says, no, I can't do this, right? And so now you look at this and you say, well, this is strange. Most beginner programmers would probably throw up their hands here and give up at this point, right? So there is an explanation as to why this results in an error, right? But the explanation is unintuitive. So if you actually read the Java language specification, right, the language says if you try to perform arithmetic with 2 integer types and both types are narrower than int, everything gets converted to an int. So if you try to use char, byte, or short, if you do arithmetic with them, the arithmetic actually gets evaluated in int. That becomes an int value, and now you get the same error. I can't store an int in E, because E is type char. Right? So but this is just the way it works, right? So if you ever find yourself doing arithmetic with char, be a little bit careful with it. Sorry, you had a question at the back. Yep. Is it not the same? No. The effect is the same as C equals C plus 1. But internally what happens is the arithmetic gets computed as though it were happening in char. So the effect is the same, right? But the meaning is technically different. And it's the technically different part that gets you into trouble. Right? So the language is defined so that if you take a char and you use the operator plus equals with an int, it will work properly. That's all that's happening. Right? The language is also defined in the way that if you take 2 types and you try to add them together with plus, it looks at the types and determines what type of arithmetic to perform. Right? So all this stuff's happening under the hood, and it's very unnatural for newer programmers to figure out what's going on. Right? But there is a reason this is all happening. The reason is because it's the way the language is defined. Okay, so you might ask yourself, so when would I ever want to do arithmetic with char, right? These are characters, they're not really numbers, right? And so the answer is if you want to write a loop using characters, it turns out it's useful if you can treat them like integers, right? So for example, if I want to generate all pairs of uppercase letters, English letters, I can use a loop, right? My first loop starts at A, right? It goes up to and including, right? So less than or equal to uppercase Z. Turns out Z is greater than A, right? Each time through the loop, I can add C, so I can advance it to the next character. Right? I can write the same loop again, this time using a different loop variable D. Right? Also starting at A, also going up to and including Z, each time stepping to the next character. Right? Now I can compute the string equal to taking C and sticking D onto the end of C. Right? So we use string concatenation. Right? So I'm going to take the empty string, I'm going to append C to the empty string, and then I'm going to append D to the end of that. Right? Why do I have to write empty string plus C plus D? Because if you write C plus D, you get char plus char, which gets converted to int plus int. And then you get the string S as an int, not as a character. Right? Not as two characters side by side. Right? So make a string, append the first character, so that's an A, append the second character, so that'll be an A. Next time through the loop, empty string plus the A, plus this is now B, right? And then AC, and then AD, and then AE, and so on to ZZ. Right? So if you run that, that will actually work. Right? If you miss the empty string, you'll get out a bunch of numbers instead, and you'll be confused. Right? You have that plus operator, right, will concatenate stuff if one of them is a string. So you have to make sure one of them is a string first. Right? And away you go. Otherwise, it performs into some sort of mathematical addition. Okay, I'm sure that was all clear as mud. Play around with the examples on the slides and try to see what happens if you change things around. Okay, so before I tell you about strings, I need to tell you a little bit about types, classes, and objects. Right? So a type, you have, I think you were probably never told exactly what a type was in Python, in your Python courses. Right? You might have heard the word type every once in a while. Right? Python sort of tries to hide the fact that there are types in the language. In Java, the types are explicit. So you need to know what exactly types are. So types are just a set of values and the operations that you can do with those values. Right? So int is a type. Right? What are its values? Well, it's the values from minus 2 billion something up to positive 2 billion something. What can you do with them? Well, you can do arithmetic. Right? You can add them to a string. Sorry, that's not the best example. But you can do arithmetic. You can compare them using less than, greater than, or equal to, and so on and so forth. Right? Okay, so what's a class? So a class in Java defines what's called a reference type. So remember, Java has two different types, right? It has primitive types and it has reference types. Where the reference types come from, they're just classes. The other way to think about this is a class is just a user-defined type. So the programmer can define a class, and now you got a new reference type. Right? An object is an instance of a class. Right? So one, the number one, you can think of it as a particular int. Right? So an object is some value that is an instance of a class. Right? So the string ABC is an instance of a string. So the class defines the type, the object is an instance of the type. So string's a class. Right? So big S string is the class that represents text, right? A sequence of characters. And it turns out to be very widely used in many types of Java programs. Right? So anything that needs to print something to the screen is going to use string. Right? So most programs end up using string. And so the language goes out of its way to let you use string almost as though it were a primitive type, right? Which is awkward for new programmers. So in other words, you can do things with strings that you cannot do with other types of reference types. So for example, string literals exist, right? So double quotes ABC is a string literal, right? There are no literals for any other reference type in the language. Right? The plus operator, so I can write S plus T, where S and T are two different strings, right? And that works. You get string concatenation. There are no other arithmetic or comparison operators defined for any other reference type. Right? So in other words, you can't use less than, greater than, or equal to for any other reference type. You can't use plus or minus for any other reference type, right? Plus, multiply, divide for any other reference type. Okay, so if you want to figure out, if you want the documentation for the string class, you can click on this link here, which I will do, just to quickly show you what Java documentation looks like. So if you've ever read the official Python documentation, the Java documentation looks very different. I would argue it's organized much better than the Python version. But anyway, so when you look up the documentation for a class, at the top you'll see the name of the class and some other stuff. By week 12, you'll know what all this you'll be able to understand what all this other stuff means. Right? If you scroll down a little bit more, you'll get a description of the class. And if you scroll down a little bit more, you'll see something called the constructor summary. For string, you generally don't use any of these. I'll tell you about constructors in a week or so. Right? You might use some, or you probably use some of the methods in string. Right? And so if you go to the method summary section, you'll see a description of the methods. Right? So anything that you see here is public, so you can use. Right? The first thing you see is the return type. Right? So char at, remember what char at does? It returns the character at a location in the string, so it returns a char. Right? So that's what the first column is telling you. The second column is telling you the name of the method and the parameters that the method has. Right? So char at requires an integer index. You get a little summary here of what the method actually does. Right? So it returns the char value at the specified index. Anything in blue you can click on. So if you click on this, it goes further into the document, and now you get the detailed documentation for the method. Right? So it tells you it returns the char value at the specified index. Right? The index is valid between 0 and length minus 1. The first char value is at index 0, the next is at index 1, and so on. Right? Down here, it gives you more information. Right? So it tells you exactly what is that parameter, right? What is returned, right? And what exceptions are thrown, if any, and under which conditions they are thrown. Right? So this tells you it throws an index out of bounds exception if the index is negative or not less than the length of the string. Right? And so if you go back, you'll see that there's many, many methods in the string class. Right? Do you need to know all these methods? The answer is no. Right? You only need to know the methods that I talk about in the slides. Right? But there's a lot. Right? So there's a lot that you might want to do with a sequence of characters. Right? Python's similar. Right? If you look at the Python documentation for str, it's also quite long. And you can easily find third-party libraries that provide even more methods that operate on strings. Right? Okay. Other things that you should know about Java strings, they are immutable, just like in Python. Did they think Python strings are immutable? Yes? Good. So once you make a Python string, you can't change the characters in the string. Same is true in Java. Right? Once you make a string, you can't change the characters in a string. Right? You can compute a string that has different characters, but then you have to, but that makes a new string object. Right? The other string object, right, your original string object, you can't change the characters in that string. If you look at that list of methods that I just showed you, it looks like a lot of them actually change the characters in a string. Right? So for example, here, to uppercase. Right? It says it converts all the characters in this string to uppercase. Right? What you have to remember is that the original string doesn't actually change. Instead, it returns a new string equal to the uppercase version of the original string. Right? The original string remains unchanged. Right? So for example, to uppercase and to lowercase return uppercase and lowercase versions of a string without modifying the original string. Right? So here's hello. Right? It's stored in a variable s. Right? If I want the uppercase version of hello, I can use s, right, and call the to uppercase method. Remember, it doesn't change s, right? So s is still hello. Right? If you want the uppercase version of the string, you have to store it somewhere if you're going to use it later on. So I need a variable up or something else to store the uppercase version of the string. Right? Now there's two strings in this class, in this code. Right? There's one here, right? And there's the second one that's been computed by 2 uppercase. Right? If you print out S, you get lowercase hello. If you print out up, you get uppercase hello. Right? The common error here is that programmers forget string is immutable. Right? So they say, well, look, I want the uppercase version of S, so I'm just going to call 2 uppercase on S. Right? If you print out S, it's still lowercase hello. It's not uppercase hello. Right? Where's uppercase hello? It's nowhere. Right? That computes uppercase hello, and then the programmer doesn't remember the return value, so it disappears into the ether. Right? So don't do that. Right? Remember, if you're doing something like this, you need to store the result variable. Right? You can write S equals S2 uppercase. Right? That reassigns S so that it's now the uppercase version of the string. Right? The lowercase version of the string now disappears. Right? But you have to store the result somewhere. Okay, so what time is it? Okay, so if you, let's go back and look at the documentation quickly. When you're reading the documentation, that's the return type, but it's also any modifiers on the method. So some of the methods are static, right? And that's all that we've used so far in the course, right? We've only been using static, or only been writing static methods, right? Now remember, to write or to call a static method, you use the name of the class to call the method, right? So if I want to use value of, I need to write big S string value of, and then something, right? Value of converts a primitive type, so Boolean char, double float int long, and so on, right? It converts a primitive type to its string representation. Right? If it's not marked static, 2 uppercase, right? It's a non-static method, which most people just call methods, right? So for regular methods, you need a reference to call the method, right? So if I want to call 2 uppercase, right, I need a reference to a string. So I need a variable of type string, right? And I'm going to write S dot 2 uppercase. You can't write just 2 uppercase. That doesn't make any sense in Java. You can't write big S string 2 uppercase. That also doesn't make any sense. 2 uppercase is not a static method, right? So you can't call it using the name of the class, right? You need a string to actually call the method, right? And so the way to think about this is that you're asking this object S to perform its 2 uppercase method, right? S holds the data, right, corresponding to the characters of the string, right? So if you want the uppercase version of that string, it makes sense to ask S to compute that uppercase version for you. So when you write S.2 uppercase, you're using the object referenced by S to call the method 2 uppercase. You did this in Python. You almost certainly did this in Python when you were using lists or something, right? You had a list T, you'd write T dot something to get T pop or T push or something like that to perform something using that list. It's the exact same thing, right? In Python, you're also calling a list method to perform that action when you write T dot. So string does have static methods. If you're going to call a static method, you always use the name of the class, right? So if I want the string corresponding to the double value 1.0, you can write string dot value of 1.0, right? The string S will be the characters 1, then the period, then the 0. Right? If you want to, though, for the primitive types, you can always concatenate the value with the empty string. Right? And it does the exact same thing as value of. Right? So if I want the string corresponding to the double value 1.0, you can just write double quotes plus 1.0. You can't just write 1.0. That doesn't work. You can't write round brackets string 1.0. That doesn't work either. Right? You can't cast a primitive value to a reference value. So those don't work in Java. One of these two will work. Okay, so strings are just a numbered sequence of characters, right? Just like in Python, similar to a Java array, but you can't use the square bracket notation, right? So every char in a sequence has an integer index starting at 0, so sys124, the first C is index 0, the 4 is at index 6, right? If you try to use a negative index or an index greater than 6 with this string, you'll get an error. How many characters are in a string? Well, that's the length of a string. Now, it's different than getting the length of an array. Right? Another confusing thing in Java, right? Java reuses a lot of names for different purposes. Right? It's also different than the len function in Python. Sorry. Right? So if you want the length of a string, it's a method. Right? So here I have a string course name. If I want its length, it's dot, length, round bracket, round bracket. Right? So you call the length method with no arguments. Right? And of course, in this case, it gives you back 7, which is no surprise. Right? The empty string is just double quote, nothing in between. Right? If you ask for its length, you get back 0. So it's possible to have a 0 length string. If you want a particular character in the string, the method is char at. You cannot use the square brackets. Right? So you have to call a method instead. You need to use a value between 0 and the length of the string minus 1. Right? So here, if I want to loop over all the characters in sys124, right, you would write a counting style loop. This is the other thing about string. There is no for each loop over a string. Right? So you can't use a for each loop to get the characters of a string. That doesn't work either. Right? You have to use a counting style loop if you want to iterate over the characters of a string. So I'm going to use an index I. It starts at 0. Right? I must always be less than the length of the string. How do you get the length of the string? Well, it's course name.length. Right? Each time through the loop, I would like to get the character at index I. Right? So that's course name.char at, pass in the index. Returns a value, so I want to store the value somewhere. I'm going to store it in a variable C, and then I'm going to print out the value on the next line. So I'll print out sys for on lines, right? C, then on the next line I, on the next line S, and so on and so on and so forth. So that's how you iterate over the characters of a string, right? Remember, no for each loop, no square brackets. To get the length, you need the round brackets after the word length. Right? And so here's a method that counts the number of times a specified character appears in a string. Right? So you can write a method that has a string as one of its inputs. So the method freq is for frequency. It counts the number of times that character appears in S. Right? How do you do this? Well, you just loop over the characters of S. Right? Each time you loop, you compare the character to target. If the two things are equal, you increase the count by 1. Right? So we start out with a count. It's equal to 0. Right? So in other words, target appears 0 times in S. Loop over all the characters in the string. Right? So start at 0, go up to but not including the length. Right? Each time through the loop, obtain the character from S. Right? So that's S char at I. Right? That's a primitive value, right? It's a char. So I can use equals equals to test if it's equal to the target character. Right? So if those two things are equal, I know that the target character has appeared one more time in the string. So add 1 to count. Plus plus count, count plus plus, count equals count plus 1, count plus equals 1, they're all fine in this case. Right? Only after you've processed every letter in the string can you return the count. Right? So there's a quick introduction to strings. I'll tell you a little bit more about them in the next lecture on Wednesday.